when we are talking about space travel, or when we are talking about traveling to Mars, okay, so it is not just enough if we have a capable rocket or capable spacecraft which can launch us to Mars, okay, so we need food, right, so that we can live. Okay, so we have a very good rocket, we have a very good spacecraft which can take us to the solar system.
How long is it going to take for us to reach
Mars? So it
Mars?
depends on...
Based on present scenario?
Yeah, it depends on at what time you are launching. Okay, it depends on...
Okay, so for the orbital thing?
Yeah, okay. So we launch a spacecraft or whatever it is, a satellite or whatever it is, okay, based on when it is near to us, then we launch those things.
Yeah.
Okay, so because if if we are in this side, if the Mars is on another side, it takes very long and it is not cost effective also. It costs billions of dollars, right? Every kilometer is very expensive. So
we need to take time.
We need to do that. Like most people think that when we are launching some satellites or some rockets, okay, so they do launch in odd timings, 3 o'clock in the morning and 12 o'clock in the midnight. We might wonder why they want to launch it in the midnight or in the odd times. Why can't they launch it at 10 o'clock? We can go have breakfast and simply go and we can come back for lunch. But it depends on
the distance.
Yeah, it completely depends on orbital dynamics. Okay. So you have a rocket which is capable of going in this specific kilometers per hour with it takes based on that satellite. It goes with a different speed. And if you want to launch a weather satellite, okay, it needs to be put in a different orbit, in different altitude, in a different inclination. If you're using defense, it requires in different altitude, right? So it based on that.
I've also heard that we also use the orbital, orbital velocity of the other planets, or even our moon, to make things travel faster, efficiently. That's what happened with James Webb Telescope or something. They launched it and they waited for it to orbit around the Earth, and when it's the right time, they just set the thrusters or something, and it went in the direction that they want to. Using that force of our orbital velocity.
No, when you are doing space travel, okay, so you require a lot of speed, okay. So to go beyond the Earth's gravity, right? So Earth's gravity is something. If you want to go beyond Earth's gravity, you need to go with a certain speed so that you can break the barriers of gravitation.
Yeah. Okay.
Okay. So for example, if you throw a ball, okay, it will come down because of the gravity.
Yeah.
If you want to throw this ball to space, okay, if you want to hit this International Space Station with this ball, okay, if you ask me, is it possible? It depends. Okay, at what speed, at what energy that you are throwing this ball. Okay. So if you can break the barrier of the gravitational pull of the Earth, you can do that, right? When when you are throwing a ball, it will come down. Whatever you're doing, whatever you are throwing up, it will come down because of the gravity. Why this rocket will not fall down when it is going to a certain height? Why it is not falling down? There is gravity, right?
Yeah.
Wherever we launch a rocket, there is also gravity. Why it is not falling down? Because we are launching the rocket at a certain speed, okay, it is breaking the barrier of that gravitation, it is going with that speed, okay. So when it is when you want to send some rocket or some spacecraft or some satellite or some whatever it is, if you want to go beyond the Earth's orbit, you need certain speed to go beyond that, okay. So you can't, you'll not easily attain that speed that instantly, okay. What they do is that they launch the rocket, okay, so it will go in that inclination mode, it will go orbit around the Earth for few times, okay, so it gets accelerated faster and faster and faster.
And then
it will be getting enough speed, okay, to break the barrier and go beyond.
Okay, and that's when they leave it to that whichever direction they want it to go.
So we talk about we talk about rockets are going with higher speed, right? So International Space Station is just 400 kilometers above Earth, okay. So it used to take a lot of hours to go. We are going in 6 hours, okay. So these days when you have to travel 400 kilometers, these bullet trains are just taking you in just less than hours, right? Okay, so even flights, if you have to travel from Hyderabad to here, which is
600 kilometers,
600 something, okay, you can just travel in an hour, just flight. If you're going on rocket, it's just 400 kilometers above you. Why you can't just go it in an hour? Why it is taking 6 hours? Because it won't happen like that. Okay, so you launch from here. Okay, this rocket will not go like that. Okay, it orbits the Earth again and again and again. Okay, so it needs to be in perfect inclination. Okay, so that is how
it moves away from Earth as it rotates the Earth, or
like what?
Okay, so it just escaped the gravitational barrier or something, and it rotates around Earth.
Yeah.
Okay, so does it move away from Earth as it rotates?
No, it's not like that. Okay.
If we want it to, it can.
Yeah, if we want it, we can. Like it happens like that. It won't orbit like this. Okay, it won't orbit like that with the same distance. If you want to go beyond Earth's orbit, okay, what you have to do is that you just go orbit like this, and the next thing you will go. You thrust up with for even more distance, and you do that. You come here and you do give it more boost.
Yeah.
It will go like that, and you go in that.
Yeah, that's what I was saying. So we are using our own gravitational pull in order to get that.
Yeah, we call it as with different names. Okay, this is what. Okay, you have to do that so that it will do that. But for International Space Station, it is not like that. It's just 400 kilometers above Earth.
It just rotates in the same orbit.
Yeah. It maintains to be around 400 kilometers above the Earth's surface. Technically.
But this thing also saves the amount of fuel or whatever we use, right? Using the gravitation to do the whole thing for us?
Not completely. There are few missions which goes to moon or something like that. We use different techniques, and scientists do experiments with a lot of things. If they don't do experiments, then we don't call them scientists. And we don't call them researchers. All their work is to do research and conduct experiments.